Hi there. So, we're diving into interactions. Chapter 10 is all about potential energy, which is really a storing of energy in interactions. So, it's really important to start off by just talking about interactions and interaction energy. I want to start off by talking about two systems. Um, the first system is going to be called System 1, and we're going to break it up into two subsystems, System A and System B. And I'm calling System 1 and System 2 more Scenario 1 and Scenario 2, but I want to look at the objects in our system here. If I have objects A and B, or subsystems A and B, I'm going to say that B exerts a force on A, right? I have FB on A, and I also have FA on B. So I have these equal and opposite reciprocal forces here, right? These are Newton's third law kind of forces. But I'm considering them as two separate objects, two separate subsystems. And so when I think about the total energy change for System 1, it's going to be, well, it's going to be the work done by the external forces, which would be then my change in kinetic energy. But if I break this work done by external forces apart a little bit, of course that's going to be work done on A plus work done on B. That's my change in kinetic energy, right? So that's our first system, System 1. Let's consider a different little system here called System 2, and I'm going to have System 2 have this one subsystem called AB, right? Instead of A and B, we're having AB. We've combined these two objects into one big subsystem, and then we're going to say there are some mediating forces here, some interaction forces here. Some interaction forces. So if I think about the same change in mechanical energy of System 2, right? I'm going to have that equal to the work externally done on the system. And the way that we've defined this, that work is going to be zero. It's going to be zero because all of those external forces, there were only two of them, but all of those external forces, FA on B and B on A, are now internal forces to the system. Their interaction works, right? They're works that are interacting between each other. They're internal works, not external works. And so I don't have quite the same setup now. Now, this energy could change, right? The system energy could change. But instead of talking about the external works, we're going to set them equal to kinetic energy, the change in kinetic energy, plus a new energy, the change in potential energy. All right. Now, if we look back to System 2 and System 1 should be the same. It should be the same because all I've done was I've kind of highlighted different regions. I put circles around different objects, right? So when I think about this, I can say that the kinetic energy, right, the change in kinetic energy, I'm going to be saying that a lot. The change in the kinetic energy is going to be the sum of these internal works now, right? I'm going to say work A plus work B is equal, well, plus delta U is equal to the change in mechanical energy for System 2. We've said that that was equal to 0 by definition here, right? So now what I'm saying is that the change in potential energy is equal to the negative internal works being done, right? The negative of the internal works being done. Work generally, if it's positive, is increasing the kinetic energy of a system. And if it's negative, right, we're actually going to increase the potential energy of the system, right? Now this only works for internal works, and we got to be careful about how we're drawing our systems here, but this energy is how much is stored in an interaction, All right, so we're going to see this a little bit more with gravity. I think that's going to be the next video, is going to be the gravitational potential energy. We'll talk about springs a little bit later, and we'll talk about why we can't have a potential energy for friction. So stay tuned, and I'll see you back here in just a bit.